Good morning, and thank you very much for the host, for the Czech Republic, for all the people and organizations that supported the idea of this meeting. I consider it of utmost importance. And for utmost importance, I mean, suppose someone comes to you and asks, how much would you be willing to pay so that the next person in the hall will not die? Well, you say, well, it's my responsibility. How much I have? I cannot spend more than I have. I would spend it all. And then the person asks you, and how much do you think we should spend so that the rest of humanity, the mankind, will not die? And for that question, we have no answer. And we have no answer because we think that's not a question. We think that humanity will survive. It has been surviving. Once I was in a meeting in the Brazilian Academy of Science, and my older brother and us were advising and making the case of the importance of tropical forests. And I was so dismayed during coffee break to talk to other scientists and to say, you're wrong. Forests are not that important. How do you say that? And she said, the Europeans cut all of it, and we are still here. So, trying to come with a new idea that overcomes a reality that people take for granted, it's very hard. And in my view, say this is supposed to say who I am or why I am here, and they tell you, I am trained meteorologist. I was trained to predict. And I was trying to remember whose professor of mine told us that the prediction business is a very serious and hard one. But much harder is to predict the future. So why is it? It's like a joke. Nobody predicts the past. But it is hard to predict the past. It is harder to predict the future. Why? Because we take for granted that the boundary conditions, the conditions in which we apply our equations in the future, will be the same, the ones that we learned them. Take water vapor. Why our models work, Anastasia? They work because we made the equations to fulfill and predict the past. We tuned the models in such a way they are good models. And once one professor, Professor George Finlander from Princeton, in a seminar he gave to us at INPE, where I work, he asked, why no models predict a permanent El Nino Southern Oscillation, ENSO? Warm Pacific, permanently warm. And we didn't have an answer, and he told us the answer. It's because you throw away all the models that do. When the model does not reproduce the oscillating El Nino, what do? We said, this is a wrong model, this is a bad model, because it does not fulfill the benchmark, that is to reproduce present climate. And I can tell you from my profession that we say it right for the wrong reasons. Our models that we feel, and the criticism to IPCC is valid, IPCC models. What is not valid is to conclude that we have nothing to do. Our tools are imperfect, but they are perfect enough to tell us that we are facing humankind threatening phenomena, that is climate change. And so I thought, well, when I read the first works of Anastasia and Victor and Anastasia was, and the phrase that came to me and came to my mind is that, oops, the sun does not circle around the earth. That was a surprise for me. Do you remember that? Do you remember the time when we thought that this earth was the center of the universe and the sun would go around? Yeah, we still do. We still think that. We see the sun coming up there, and Anastasia's and Victor's work for me was that realization that no, it's not the sun that goes around the earth. It's the other way around. And the other way around means our mind frame. We were taught from beginning that the sun is important, the atmosphere motions, and the oceans were important. And because we learned to regulate our models with this sun, water, and energy cycles, we could predict weather and seasonal climate, more or less. We thought we knew it all, but we didn't. We don't. Because we didn't learn the importance of life. And Jim Lovelock with Gaia was the first, maybe not the first, but one fourth stronger person that proposed that without life, our atmosphere would be completely oxidized. So there has to be life, there has to be photosynthesis, that is something that counteracts an oxidizing capacity of oxygen. And so life sciences becomes a central question on our task of predicting the future. And my whole, I'm not a biologist, I understand very little, nothing actually. Oh, well, if I understand nothing of the things I do, imagine the things I don't do. Absolutely ignorant on the thing, but this is a challenge that we have ahead of us, is to how we deal with mind frame in which says forests are a consequence of climate, not the driver. And then we come to another point. We are not doing this for publication on Nature. If we are, great. We need a next supercomputer, some theorists, we write papers, and we will be done. But if we are indeed aiming at being a change, a force of change in humanity, like the great philosophers and scientists did in the past, we need to understand the nature of the problem. We were discussing this yesterday. At the table, what is the first thing to solve a problem? Is to be able to formulate the question. What is the question? Is it a problem of supercomputer? Is it a problem of lack of resources? I will tell you, we are talking here about internal combustion engine of biofuels. We are talking about the past. Think about a few years ahead, when fusion, not friction, when fusion becomes mainstream. Energy will be so abundant that we will refuel an airplane every 60 years. So if we are thinking about changing the future, we must consider the boundary conditions in which the future will be. Otherwise, we will be talking to the past. When we get there with our new car, have you seen this film called Back to the Future? With the DeLorean? The cars will go back and forth in time. And we will talk about internal combustion Ferrari. Our kids will say, "Oh, Dad," or "Grandpa, or Dad, maybe not Grandpa. You are lost in time." So back to our mission. What is the question? I kept listening to things here, and I keep asking myself, what is the question I want to answer? What you rightly put there. Because if we don't have that very clear ahead of us, I will tell you, we are wasting our times. We are. We may make a lot of money. We may make a lot of papers, but is that our question? Yeah? And so my question is maybe a little further. I'd like to push this here, because we are in a place, in a moment, in which we put ourselves to defy common wisdom. Because if we're not, we would not be here. And I will say one thing for me, that's the common wisdom that has been ignored by science altogether is love. We don't have an equation for love. And still, love is what you see in Antonio's presentation about the forests. An animal, predator and prey, will never extinguish each other. And I might lose my audience, and I have tried several times. When I talk about love, people don't understand. What are you talking about? We're talking about science. I came here to hear you talk about climate. I say, yeah, that is the first hole. The first is 101. So, and let me try to make a sense in why I'm here in climate modeling and love. It's because I frankly, from the deep of my heart, I tell you, we forgot our own nature. We are talking about the nature, we are talking about trees, and I have a very nice BBC storytelling here. I received, if possible, if someone high-tech could grab it from my phone and present there, I would like to show you about how trees communicate through the root system. It's really crying. The intelligence the trees have to communicate danger, to pass substance to each other, resilience. Like Anastasia's mentioned, how did the nature be so resilient throughout times, ages? And our civilizations, Mesopotamia, how much knowledge we have already had that disappeared, vanished. We missed something in this puzzle. Now, we are intelligent. We have a brain. We can speak. We can write a poem or a symphony. Have you heard the Ninth Symphony of Beethoven? That is a miracle, a work of science, of love. So we are these ones. These are these elements in nature that we can compose a music, and we can destroy people with atomic bomb. We are the same ones. And we are now living a threat that is a humanitarian crisis. That is global climate change. If you have seen the report of the SR 1.5, the special report on 1.5, imagine that a special report written with the agreement of many governments, all the governments, say that we have merely 12 years to avoid maybe further drastic consequences. That's losing the whole coral reefs, of flooding all our coastal cities. And the actual dangers are not written in the report, because of the the inertia of the natural system, like methane, carbohydrates liberation in a warmer climate, in which we can plant the whole planet. We can change the whole cars to electric, and that will be irrelevant. That is where we are facing it. And imagine that we are a United Nations body, and we have the mandate to ask us, what shall we do? So planting trees, being able to contemplate the importance of forests in our model is what we can do. But we are ahead of a much larger, my view, problems is to understand our role in nature. We may not be able to act because we don't have the tools to it, but in my view, and I am opening my heart to you, that's the reason why I don't have a presentation. I wanted not to follow the things I thought before, but I wanted to let it flow with you guys here now and shape what I had to say, is our spiritual nature. If we don't understand that we are spiritual beings that think, in my view, we shall sit and watch the film that is going to unfold ahead of our eyes, right here, right now. Just imagine, we are just before the beginning of the Second World War. But before that, all those movements, and some people say, oh, don't worry, they don't be crazy to doing this. And we could avoid it. We couldn't. The Second World War was necessary so that we could maturate and say, never more, not that again. Now we are ahead of something that is much bigger. It's the whole mankind. And so coming from my ground, now my scientific ground, so there is a time in which the oceans start to release carbon. And the permafrost, the frozen soils, start to release methane. At that time, there's nothing that we shall do other than small communities approach like Martian. Your village, your term, droughts will be perennial, and it will be. And at that time, then I would like to address the question of economy. Economy is a concept of the past. Money only has value if the fields are producing food. If we have a permanent drought, money has no value because we have no food to eat. It doesn't matter. If you have a hurricane flooding the whole city, what matter how much money you have in the bank account? Nothing. So the economic payback is an old concept. And I can tell you this coming from a country. I learned this recently. The economy is so, it's another ball game, but I must tell you, you know how much we pay yearly in Brazil in interest in our debt? The amount of the Marshall Plan that recovered Europe after the Second World War. That's the amount of money that we pay every year in interest in our debt. So, what are we? We are slaves. We are slaves. Maybe I have overpassed my duty here to tell you this, but I need to share with you. My disposition is full to contribute in the modeling aspect of predicting and incorporating the biotic pump concept in our models. And this is a contribution that we group can do that is solid in terms of saying why IPCC models, mine included, are failing to predict the rate of speed in which climate is changing. All models are right in the direction, but wrong in the speed. And the reason, I think, is because, you know, this parking brake in the cars, we are accelerating our cars with our models with the parking brake. Pull it. So, thank you for the presence.